Hello, this video is for IXL Activity A1.C.2. It is titled Write in Equivalent Ratio, and the 3-character code for this activity is Romeo Whiskey 6. So dealing with ratios, we did ratios in a previous activity where we found equivalent ratios. We were given a couple ratios and we had to determine whether or not those ratios were equivalent. This time they're going to give us a missing number of one of the two ratios. Here it says find the number that makes the ratio equivalent to 4 to 8. So we need to know what ratio, if 8 is our first number, what number needs to go in the blank for these two ratios to be equivalent. So 4 to 8 is equivalent to 8 to blank. Well, one thing that we remember is that ratios can be represented as fractions. So let's go ahead and use that strategy of representing ratios as fractions, and then we'll just put an X for the value of whatever's missing. We'll set it up that way. So let's take this first ratio here, 4 to 8. Well, we know we can set that up as a ratio of 4 over 8, right? 4 to 8. Ratios, remember, can be written as, we could write this as 4 to 8, use the word to. We could also use a colon and write 4 to 8, which is what we're using here. Or the other way to do it is to write it as a fraction, 4 to 8. So we're going to convert the ratios that use colons, we're going to convert them over to fractions, because that way we could go ahead and set them equal to one another. And remember, the first number is always our numerator, and the second number is always our denominator. So we'll put X there for the unknown value. So we need to determine what is happening to the two numbers that we're given that are in the same position. So here we have both numerators. We're missing a denominator. So to get from 4 to 8, and let's think multiplication or division, I could say, what do we do to 4 to get to 8? And you say, well, you add 4. Let's think in the terms of either multiplying or dividing. So 4 times some number equals 8, and that number's 2. So in order to have an equivalent fraction, which is going to give us an equivalent ratio, we want to do the same thing to the denominator as well and multiply that times 2. So 8 times 2 is 16. So we could go ahead in the blank here, we'll go ahead and put 16. So 4 to 8 is equivalent to 8 to 16. You also notice if we divided these, 4 divided by 8 is 0.5. And you could always check your work. 8 divided by 16 is also 0.5. Remember, we talked about how to check if two ratios are equivalent by going ahead and dividing the numerator by the denominator, because that's right, you've guessed it, every fraction is indeed a division problem that we could always convert to a decimal number. Let's look at the next one. Here we're given 1 to 6, so let's go ahead and write that, 1 to 6. Remember, the first number is the numerator, second number is the denominator. Let's go ahead and set that equal to the other fraction we have. Here we're missing the numerator, so we're going to go ahead, or the first number, we'll set that in the numerator, and we'll go ahead and put 48 here in our denominator. So 1 to 6 is equal to something to 48. So let's look at what we got here. Some number, and it's multiplication because it's getting bigger, right? Some number times 7 equals 48. Well, that number is 8. So let's go ahead and multiply 1 times 8 as well, and we'll see that 1 times 8 is 8, so X equals 8. In this case, we'll fill that in. Now, sometimes it may not be as obvious. Maybe you're like, I don't know what number times 6 equals 48. Well, you could always take the larger number, in this case 48, and you could divide it by the smaller number, which is 6, and then you would find out that 6 goes into 48 8 times, and so you realize that the factor that 6 is being multiplied by will give you the product of 48. So that's how we got from 6 to 48, was by multiplying by 8, and we did the same thing to the numerator to find our missing value. On the next one, find the number that makes the ratio equivalent to 8 to 2. So let's go ahead and write that 8 to 2, and we're going to set that equal to some number over 22. All right, not too bad, right? Some number times 2 is 22. Well, that number's 11, right? 11's are pretty easy. So we're going to do the same to 8, multiply that times 11 as well, and X is going to give us 88. We'll go ahead and fill 88 in there and go ahead and move along. Find the number that makes the ratio equivalent to 3 to 11. So we have 3 to 11. And we're going to set that equal to x over 88. So we can find that missing value that we have here. All right. Gee, this is kind of like the last one we had. 11 times something is 88. Well, we know our 11, so that's times 8, right? Let's go ahead and multiply our numerator by 8 as well. And 3 times 8 equals 24. So 24 is our missing value. On the next one, find the number that makes the ratio equivalent to 35 to 70. 35 to 70. We're going to set that equal to 7 over x. All right, notice this time the number is getting smaller, right? Lesser in value. The value is actually decreased. So instead of multiplying, we're dividing, correct? And what are we dividing by? Well, 7. 35 divided by some number equals 7. Well, that number is 5. If you were uncertain about that, you could do 35 divided by 7, and that would tell you that you're multiplying times 5. So I don't know if I'm getting that kind of mixed around there. But so let's go ahead and divide 70 by 5. Well, if I had 5 times 10, it would give me 50. And it's another 20 to 70, right? So 5 times some number is 20. That would be 4. So in this case, I'd end up with 14. So 70 divided by 5 should be 14. Now we could double check this, right? If you were like, okay, I think I got it right. You could go ahead and simplify that to fractions. So 35 divided by 70. Well, I happen to know that 35 is 1/2 of 70. So over here I would have 0.5. And 7 is 1/2 of 14. So over here I would have 0.5 as well if I were to divide 7 by 14. So they both work out to the same decimal number, so I know that my answer is indeed correct. So let's go ahead and put that in there, 14. On the next one, I have 72 to 32. 72 to 32. And that is equal to some number over 4. Look, they've actually given us a fraction. They stopped using the colon for the ratio. Now they're using it and writing it as fractions for us, so we don't even have to convert it. All right, so then we'll put x here for the unknown value. Now, 32 divided by some number equals 4. Well, I believe that's 8. And for me, 32 is always a tricky one. I'm always thinking it's 8 times 4 and 9 times 4. And my brain always says 8 times 8 is 16, or 8 times 2 is 16. And then double 16, well, 6 and 6 is 12. Oh, it's the one that ends in a 2. Or whenever it comes to 4 times 9, my brain thinks 99 is 18, 8 and 8 is 16. Oh, it's the one that ends in 6, so it's 36. So after all these years, you would think I'd memorize it, but my brain still does that every time. It's kind of strange, I suppose, maybe. So let's divide the numerator by 8 as well. Oh, well, if I know my 9s, I know that 8 times 9 is 72. So 72 divided by 8 must be 9. So my answer is 9. On the next one, let's do 24 is to 20. Not too bad, are they? These aren't too terribly difficult. At least I don't think they should be. So the numbers get smaller, so we know that we are dividing. And what number are we dividing by? That number would be 4, because 6 times 2 is 12, and 12 double is 24. So 6 times 4 is 24, therefore 24 divided by 4 is 6. So let's go ahead and divide 20 by 4 as well. If you know your 5s, you know that 5 times 4 is 20, so therefore 20 divided by 4 must be 5. So our answer is 5. Here we have 63 to 18. And we want to go ahead and compare that to x to 2. So 18 to get to 2. Well, I know that 9 times 2 is 18, so I must be dividing by 9. So let's go ahead and divide the top by 9 as well. And 9 times 7 is 63, so 63 divided by 9 equals 7. So our answer is 7. And my final example here, I have 21 to 25. And so we're going to set that equal to x over 75. So the value's gotten greater, so we're multiplying, right? What number we multiply by? 25 times 3 would be 75. So let's go ahead and do the same to 21. 21 times 3. Well, in this case, 20, here's my mental math, 20 times 3 is going to equal 60, and 1 times 3 is going to equal 3. So therefore, 21 times 3 must equal 63. See, I'm adding these two together, and then I'm adding these two together, knowing that I'm multiplying by 3, so x is going to give me 63. 63 over 75. All right, and that concludes all of my examples for IXL Activity A1.C.2 Write an Equivalent Ratio. Good luck with your activity.